Once again I welcome you to this course and this lecture on foundation engineering, and that too in a particular topic like stability analysis of earth retaining wall. And in the previous few lectures I have discussed about the earth pressure calculation. Now actually in the foundation engineering, in the soil mechanics generally that is the part where actually we discuss about in more detail about earth pressure calculation and all, but in foundation engineering actually finally you have to design the retaining wall. So, there while designing two parts are there. One part is structural design, that there actually if it is a concrete is used, then sometimes you have to take the help of structural engineer, and but as a geotechnical engineer what you have to do, you have to do the stability analysis. Stability analysis means you have to understand that what are the different ways wall can fail, and there are three distinct mode of failure. In fact, fourth one is there which we will not discuss. The first mode is actually overturning. If the wall is too high suppose and it retains the backfill, then there is a chance of toppling the wall with respect to toe. That is one thing. So, that you have to make sure that there is a sufficient factor of safety against toppling. So, that is one thing to be ensured, and second thing is next, if the pressure is too high, then sometime and if there is not much fixity on the base, and then there may be because of the high pressure entire wall may slide towards away from the backfill. So, that base sliding, that is called base sliding. So, that means when there is a wall and when there is a pressure, there will be sufficient amount of vertical pressure, and then below the base of the wall there will be some resistance will be there, and then that normal pressure, that base resistance will be how horizontal frictional resistance will be what, that will be normal multiplied by the tan phi. Okay. So, that one tan delta. So, that way you can calculate the base resistance, and when it is the wall is pushed horizontally by active pressure, then it will be prevented by that resistance only. So, you have to see to make sure that base resistance is much higher than the horizontal push by the active pressure. That is second one, and third one is when there are a number of forces acting on the wall. For example, there is a gravity weight because of the gravity, that means self weight of the wall, that will be act vertically, and sometimes there will be some amount of soil weight also will come into the wall, that also will be acting vertically on the wall, and then whether it is active or passive pressure, that will be acting horizontally, and if there is a inclined backfill, that will be acting parallel to the backfill slope, and then you can take into two component, one is vertical and horizontal. Vertical actually component will give you the vertical pressure on the base, and horizontal pressure will give you the push toward away from the backfill. Now, when there is number of forces acting, then all the forces will act somewhere which will be may not be through the centroid of the base of the retaining wall. When this happens, that means when the wall is there, when there is a particular structure is there, and here the compressive force acting through its centroid, then there will be compressive pressure throughout the base of the wall, and there is no issue. Then how you can find out? Total load divided by the area of the base, total compressive force. But when there will be a number of forces are acting like horizontal pressure, vertical pressure, something else like soil pressure and gravity weight, and then if we calculate resultant, then we may find that vertical pressure will be is acting somewhere other than the CG. Then because of this eccentricity, that means the force is acting away from the distance from the CG, and that distance is called eccentricity, and when that happens, then in addition to the compressive load, the footing subjected to some amount of movement. When the footing is having a movement, a vertical load in addition to a couple like this, then what will happen? Because of the compressive load, there will be compressive pressure, because of this couple, one side will be tension, another side will be compression. So, that means compression plus compression, one side will be a high compressive pressure, another side will be tension minus compression, there will be some amount of little bit of compressive pressure. Sometimes if the tension is becoming much higher than the compression, then it will be tension also. That means one side will be without any contact. So, that means because of this eccentricity, what will be the pressure distribution below the base of the retaining wall, we have to find out, and we have to make sure that there is nowhere the tension is occurring. At the same time, when there is a high compressive pressure, and we have to make sure that that compressive pressure will be much below than the bearing capacity of the soil. So, this thing you have to check. So, for that actually I have taken one problem, and I will try to show all those things one by one, how to calculate those stability, that means factor of safety against different condition. You can see here this wall actually is actually 5 meter high, and you can see there is a gravity retaining wall, and this back side is vertical, and it has a 2.7 meter width at the base, and this wall is perpendicular to the board. I can consider a infinitely long, it can be long enough, which I consider as long enough, and for that I can analyze for the unit length. So, that means I can take this base I can consider as 2.7, this is 2.7, and I can take unit width of 1 meter, and that means that is front view, and this is the top view of the wall. Top view, it is not really top view will see only this top, only this one will see 0.6 meter, but at the base top view for the base is like this, and its CG will be somewhere here like this, and you can see here this angle is not mentioned. Suppose I will take 15 degrees, and it is retaining a granular backfill with 17.3, it is not 3, it will be 17.5 kilonewton per meter cube, phi is 32 degrees and it is 5 meter height, and gamma c instead of 23 I can take 24 actually kilonewton per meter cube, and there is a toe side 1 meter is there. So, theoretically this side there will be active pressure, and this side because of this weight wall will try to move this way. So, because of this it would be active, and because of this active pressure this side wall is pushing this side. So, that means this is passive. So, this side will be P p and this side will be P a, but for the stability analysis purpose. So, this is actually this P p force will give you extra stability to the wall. So, if I ignore this one and find out that it is safe, that will be really safe. Okay. So, because of that will be some conservative side we can do. So, I will in this problem I will ignore this P p side, I will only take the active pressure from this side, and whatever relevant things are required I will take, and I will try to do the analysis ignoring the passive part. So, let me do one by one. First of all clean this and go to the next slide, and suppose I will create a new page, suppose this one, and the wall is your 5 meter high, and it is inclined, and from the Rankine's theory what we have learned, though Rankine's theory is a horizontal backfill, but we have learned that when there is a incline we have got expression for K a equal to cos beta minus under root cos square beta minus cos square phi divided by cos beta plus under root cos square beta minus cos square phi. We have got this expression, and then we have also shown that the pressure will be finally resultant pressure will be acting parallel to the backfill slope. So, something like this. So, I can imagine the pressure will be acting like this, it will be triangular suppose from here, and this is the pressure diagram I can imagine. Okay. and if I do that, so at this point actually your pressure will be equal to 5 multiplied by, and Ka, if I put all those, if I put the value of cos beta equal to 15 degrees and phi equal to 32 degrees, if I put in this expression, and then finally I will get Ka equal to 0.34. Okay. And then I can find out here 5 into multiplied by gamma is 17.5 and multiplied by 0.34, that means this become your 29.75. Okay. And then I can find out P A, that means active pressure will be equal to half multiplied by 29.75 multiplied by 29.75 multiplied by your 5. Okay, so that will become your 74.375, and suppose this is the one. So, it is acting at some angle. So, I can imagine this one as vertical and horizontal. So, this one I can say as PAH and this one I can say PAV. So, if I consider that, so PAH will be equal to, this angle is actually 15 degrees. So, that will be PA cos beta. So, this will be PAH will be equal to 71.84 kilonewton, and PAV will be equal to PA sin beta, and that if you calculate that become 19.25. Okay. So, now this we have got, and then in addition to that, suppose there is a wall dimension I will just draw now, and it was something like this. So, this is suppose W1 and this is suppose W2. So, I can calculate W1 will be equal to 0.6 multiplied by 5 multiplied by 1 multiplied by 24 concrete weight. So, this become your W1 become your 72 kilonewton, and W2 will be equal to half multiplied by, this is 0.6, that means this one is 2.1. So, it will half multiplied by 2.1 multiplied by 5 multiplied by 1 multiplied by 24, that gives you W2 become 126 kilonewton. Okay. So, now I have, that means how many forces are there, W1, W2, PAV and PAH. So, that means I can find out P vertical, total PV will be equal to W1 plus W2 plus PAV. So, that gives you PV equal to 217.25, and that means, so factor of safety against sliding, suppose it will be actually resistance will be PV multiplied by frictional, actually is given 0.5. Frictional resistance at the base will be equal, is given as 0.5. So, PV multiplied by 0.5, that is actually resistance, and what is the horizontal force, actually it will try to push the wall for sliding, that is PA horizontal 71.84. So, that will be equal to 71.84. So, if I calculate this, and that gives you a value equal to 1.51, and in fact, it is in the Indian code, what should be the factor of safety required for factor of safety against sliding, it is given. You do not have to remember, generally it is 1.5 and it is greater than 1.5. So, that means against sliding it is okay. Okay. And now factor of safety against overturning, factor of safety against overturning. So, overturning, what will happen? You can see this force is acting here, this force is acting here, and PV also acting along PAV, that is PAV that is acting this. So, these three forces acting. So, if overturning will be when the wall will overturn, that overturn will be with respect to, that means the pressure is from this side. If at all overturn, it will overturn with respect to this point here, this point here. So, that means it will be overturning like this. So, that means when, since all the vertical forces are acting this direction, so it will be resisting force. So, that means resisting moment MR divided by overturning moment A O T. So, MR will be how much? That means W 1 multiplied by, what is the distance from here actually? It will be 2.1 plus 0.3. So, W 1 at this much distance is acting, plus W 2 in multiplied by how much distance? 2/3 of 2.1, 2/3 of 2.1 plus PAV multiplied by how much distance? 2.1 multiplied by 2.7 multiplied by sorry, that will be at 2.7, that will be at 2.7 divided by overturning moment is what? Overturning moment is PAH multiplied by how much at a distance? It will be 1/3 of 5. So, if I put all the values and then simplify and calculate, then you will see that if I put all those values here, and you can get the then you will get ultimately it will be 401.175 divided by 119.733. So, and that will come actually 3.35. 3.35. Okay. So, this is actually factor of safety. So, it is a quite good value. So, it is also okay, looks like, and whether it is okay or not, what is the factor of safety desired, that will be given, and one can decide that what value actually required, whether okay or not. If it is not okay, obviously you have to change the dimension and you have to redesign. Oh, sorry. And then next page actually I will go. Suppose you have to find out now the factor of safety against base pressure, and you can see now that we can find out the where actually CG is acting. Suppose this is the base of the this is the one, and different forces are acting at different point. So, I can find out that vertical pressure, resultant vertical pressure acting somewhere here, and then or in some angle actually acting pressure and maybe some angle, and then I can consider vertical and horizontal, and so suppose this distance is suppose x bar. So, x bar multiplied by suppose PV will be equal to that restoring moment minus overturning moment. So, that means W 1 H 1 plus W 2 H 2 plus PAV plus PAV multiplied by H 3 minus PAH multiplied by H 4 suppose divided sorry, this should be equal, this to be equated, and then I will get x bar will be equal to W 1 H 1 plus W 2 H 2 plus PAV H 3 minus PAH H 4 divided by PV. And if I put W 1 H 1, I have shown in the previous page calculation, W 1 H 2 H 3, H 4 also I have mentioned, all those things there. So, I have put all those values, and then I will get this value equal to 1.299 or so. So, approximately suppose 1.3. Now, if I consider now the base of the footing, suppose this one, and this is 2.7, base of the footing is total 2.7, this is 2.7 means this is 1.35, and that means force is acting somewhere here from this is 1.3. That means E will be equal to 1.35 minus 1.3, that means 0.05. That means your M will become PV multiplied by E, and PV actually we have calculated how much. PV was whatever was there, and that if you multiply, PV was 217.25, 217.25 multiplied 0.05. If I do that, then it comes around 10.86. M become 10.86. And now I have discussed also bearing capacity time, that when there is a eccentric moment is acting, then I can consider the force eccentric force is acting, that force can be considered at the center in addition to a moment. So, when PV and M are acting together, then your sigma become PV by A plus minus My by I. This is the formula. So, this formula if I use, then you can see, then it will be 217.25 divided by A is how much? A is nothing but 2.7 multiplied by 1, this is 1, and plus M become 10.86 multiplied by Y will be how much? This is maximum distance 1.35, and your this is rotating with respect to this axis. So, your I, so I become 1 multiplied by 1.35 cube divided by 12. So, then I can find out sigma max and I can find out sigma minimum. So, if I calculate this one, then it become 80.46 plus 80.46 plus 71.05 or 70.5. So, that gives you 151 point or at approximately 152, and sigma minimum will be 80.46 minus 71.5, and that gives you approximately 8.96, that means around 9 kilonewton per meter square. Okay. So, that means this side your pressure is 152 and this side is only 9, and you can see that from this distribution you could make sure that eccentricity actually small, very small, and eccentricity should not be greater than B by 6, and B is this B by 6 whatever value you calculate, and you can see less than that. That is one thing, and you can see that we want to make sure that there is a no tension below the footing. You can see here also this is also positive, this is also positive. So, in between also it will be positive. So, if I draw the pressure diagram below the retaining wall, the pressure diagram will be something like this. So, this will be maximum here and this will be minimum. So, this one will be 9 and this will be 152. So, that means throughout the base of the footing it is positive value. So, this is actually sufficient now, that means we have got the positive pressure throughout the depth. Now, if you want to find out factor of safety against bearing capacity, then if suppose soil bearing capacity is given, suppose 500. Okay. So, factor of safety against BC bearing capacity, suppose 500 divided by 150, 152. So, whatever value it comes, that will be very quite close to suppose 3, 2.5 to 3 actually generally desired. So, that means it will be okay. If it is not, obviously you have to change the dimension of the footing, either base or height, all those things to be changed, and accordingly so that after analyzing this we get the expected value which is desired. Okay. So, like this we can solve the problem. Now, this is one type of problem I have taken, but this problem actually I have taken like the slope. Instead of slope, it can be only horizontal. So, this is not there. If it is horizontal here, then your directly your P active was here, there is no need of making component, and in that case we will have only only 1, 2 and this is 3, only 1, 2, 3. This is one type of problem. I have taken little complicated, that means I have taken sloped backfill. So, because of that this pressure was like this, and then I have taken two component at a PAV and PAH, and then I have to consider 4 forces, and then I have done the stability analysis. Sometime instead of the vertical back, the wall can be, cross section of the wall can be something like this and maybe something like this. If it is so, then what I have to do? I have to, while doing the stability analysis, from this point I will draw a vertical line from here, this vertical line. So, I will consider this as the wall, this as the wall, and I will calculate PA acting here, and that means I will divide this self weight, that 1, 2, this is 3, and this soil weight also will be coming in the on the wall, assuming that I have to consider this weight of the soil also as a fourth part, and then rest of the analysis will be similar. I have to find out factor of safety. First of all vertical forces I will calculate, and then vertical force multiplied by the friction, I will get the resistance, that divided by the horizontal pressure, that will give you factor of safety against overturning sliding, and then for finding out the factor of safety against overturning, what I have to do? All the forces 1, 2, 3, 4 all are actually this side. So, these are all restoring. I have to find out CG of all those, P1 H1, P2 H2, P3 H3, like that I will do, and overturning moment will be this PA multiplied by this height, and from there I will get the factor of safety against overturning. Similarly, for finding out the bearing capacity, I have to find out the resultant point of application. If it is not on the CG, then I have to find out the eccentricity, then find out moment, then apply the equation sigma equal to P by A plus minus My by I. By this equation you have to find out sigma max and sigma minimum. So, that is another type of problem. Then another type of problem also possible, that is actually, suppose the wall is similar, suppose like this, like this, like this, and in addition to that it is slope backfill. Here actually what I have to do? I have to draw vertical line and I have to go up to this slope. Then suppose the wall height was something like, suppose 5 meter, and now this slope angle was something, then I have to consider this height also. Now height h modified I have to calculate, which will be equal to h plus this height, h plus this height. So, this height how I will find out? I know this, I know this angle. So, from there I can find out this. So, if this is the type of problem, then again I will do similar way, 1, this is 2, this is 3, and this will be 3, this will be 4, and you can ignore either this weight or you can consider another part 5 also, and like that 1, 2, 3, 4, 5 component will take, and then rest of the calculation is similar. PA will be acting somewhere at a distance h by 3, and then find out resistance, then resistance divided by horizontal pressure will be factor of safety against sliding. Then you can find out restoring moment, find out overturning moment, ratio of that will be factor of safety against overturning. Then find out the CG, the point of application of the resultant force. If it is not in the middle, find out eccentricity, eccentricity multiplied by vertical force will be your moment. Once you get the moment, it will be sigma max, sigma minimum will be equal to PV divided by area plus minus My by I, and while calculating I, actually always you have to calculate this as a base and this as a height, okay, because it is rotating with respect to this axis. So, like that, whatever may be the type of problem, you have to the problem I have solved. If additionally this type of slope is there, back slope is there, then what I will do? From the hills point I will draw a vertical line, and up to the ground surface I will grow, and then I will see if it is a level backfill, then height will not change. If it is a sloped backfill, height of the wall will be modified, it will be more than the actual height, that to be calculated, and considering that height of the wall, you have to calculate earth pressure and then all the things, otherwise all rest of the things are similar. So, I will take another problem also in the next class maybe, and then I will show some more that whatever if it is how to modify height and all those to be calculated and stability analysis will be done, that I will show in the next slide. Thank you.